There is a moment from your life that you will never get back. Maybe it was a conversation with someone who is gone now. Maybe it was a single afternoon, the light through a window, the smell of something cooking, a feeling you didn't know you were memorizing until it was already over. You reach for it in your mind, and you find the shape of it, the outline. But the thing itself? Vanished. That's what we tell ourselves. The past is gone. It happened, it mattered, and now it doesn't exist anymore. It's the most obvious thing in the world. Yesterday is not a place you can go. Last year is not a room you can re-enter. The past, by definition, is the thing that is over. Except physicists started doing the math. And the math said something that should have caused riots in the streets. Something so strange, so counterintuitive, so quietly devastating that most people walk past it every day without ever knowing it's there. The math said, the past doesn't go anywhere. Not as a metaphor. Not as poetry. As a literal, geometric, possibly testable feature of the structure of reality itself. And here's where it gets worse. Or better. Depending on your disposition. It's not just that the past persists in some vague philosophical sense. Some physicists, serious ones, with serious equations, believe that every moment that has ever happened is just as real as this moment, right now. That 1987 is not a memory. It is a location. That the version of you at age 7, scraping your knee on the pavement, is not a ghost of the past. That child is still there, still existing, still in that moment, in a direction we simply cannot travel. Time, on this view, is not a river that flows and disappears. It is an ocean. All of it, always, everywhere at once. Now, before you dismiss this as the kind of thing people say at 2 a.m. after watching too many documentaries, let's look at the evidence. Because this idea doesn't come from philosophy departments full of people arguing about whether trees make sounds. It comes from the same framework that gave us GPS satellites, nuclear reactors, and the device you're watching this on. It comes from Einstein. Let's start with something simple. Something you've known your whole life, without ever realizing how strange it is. Look at a candle. The light from that flame reaches your eyes in a fraction of a nanosecond. Basically instant. Fine. Now look at the moon. It's 384,000 kilometers away. The light bouncing off it takes 1.3 seconds to reach you. So right now, you are seeing the moon as it was 1.3 seconds ago. Not the moon as it is. The moon as it was. Look at the sun. 8 minutes of light travel time. You are watching a star from 8 minutes in the past. If the sun vanished right now, just blinked out of existence, you wouldn't know for 8 minutes. You'd be sitting there in sunshine, making plans, and the star that makes all life on Earth possible would already be gone. Look further. The nearest star beyond our sun, Proxima Centauri, 4.2 light-years away. You see it as it was 4.2 years ago. The Andromeda Galaxy, the closest major galaxy to ours, 2.5 million light-years away. When you look at Andromeda on a night, you are receiving light that left that galaxy before Homo sapiens existed. Before our species took its first breath, that light was already traveling toward your eyes. And the deepest images we have, the ones from space telescopes capturing the farthest reaches of the observable universe, those are showing us galaxies from 13 billion years ago. Nearly the beginning of everything. Here is the thing nobody pauses on long enough. You are not looking at the past like you look at an old photograph, a representation of something that is gone. You are receiving actual physical information from those moments. Real photons that were emitted in the actual past are landing on the actual retinas in the back of your actual eyes, right now. The past is not just a memory. It is arriving. Every time you look at the night sky, you are holding a window open into history. The universe is constantly sending you mail from moments that are supposedly over. And that mail is real. Physical. Measurable. So here is the first crack in the obvious story. The story that says the past is gone. If the past is gone, why does it keep showing up? Why does the universe still carry all this ancient light, all this ancient information, traveling faithfully across billions of years, as if those moments are still somehow sending? Because here is what physics will tell you, if you push it hard enough. Information doesn't just disappear. Light doesn't lie. And if a moment in the past is still broadcasting, still producing real, physical, detectable effects in the present, then in what sense, exactly, is it over? We've barely started. And the ground is already shaking. Here is something your brain will resist. There is no such thing as now. Not globally. Not universally. Not in any way that physics is willing to defend. The word now, the most basic, most obvious word in the human experience, turns out to be a local illusion. A useful fiction. A shortcut that works fine when you're making breakfast but completely collapses the moment you try to apply it to the actual structure of reality. This is not a philosophical opinion. This is special relativity. published 1905, tested 10,000 times, built into the infrastructure of the modern world. Let's back up. Before Einstein, time was simple. Time was Newton's time. And Newton's time was a river, steady, universal, flowing at the same rate for everyone, everywhere, always. Whether you were a peasant in medieval France or a photon hurtling across a galaxy, the clock ticked the same. 1 second here was 1 second everywhere. Time was the backdrop. The stage. The thing that everything else happened inside of, but which was itself untouchable. Absolute. It felt so obvious nobody thought to question it. Except Einstein. He started with something almost childlike. A thought experiment. He asked, what would you see if you chased a beam of light? If you ran alongside a sound wave fast enough, you could match its speed. The wave would appear frozen to you, a static compression of air, going nowhere. So what if you did the same with light? What if you accelerated until you were neck and neck with a photon? Would you see a frozen ripple of electromagnetic energy, standing perfectly still? Maxwell's equation said no. The speed of light is constant. It doesn't matter how fast you run toward it or away from it. Light always moves at the same speed relative to you. Always 299,792 kilometers per second. No exceptions. No negotiations. Einstein took that seriously. And he followed the logic wherever it went, even when it went somewhere insane. If the speed of light is constant for everyone, regardless of how they're moving, then time cannot be constant. Time has to bend. It has to stretch and compress to make the math work. Because the only way the universe can keep the speed of light fixed for everyone is if it messes with everything else instead. And the thing it messes with most is time. Here is what that actually means. Two people. Call them Anna and Ben. Anna is standing still on a platform. Ben is on a train, moving at an enormous fraction of the speed of light, let's say 60%. A lightning bolt strikes both ends of the train simultaneously. Anna sees both strikes at the same moment. Simultaneous. Clean. Obvious. Ben, moving through those same light signals, receives them at slightly different moments. For Ben, the strikes were not simultaneous. One happened before the other. Same events. Same physical reality. Different time ordering. This is not a trick of perception. This is not about where the light happened to hit their eyes. This is about the actual, physical structure of time. In Ben's reference frame, his legitimate, physics-endorsed, equally valid frame, the events happen in a different order than they do in Anna's. There is no master clock floating above both of them that says which one is right. They are both right. Simultaneously, and here's the irony, the concept of simultaneous no longer has universal meaning. Let that sit. Events that you see as happening at the same time, right now, in this moment, a sufficiently fast-moving observer somewhere in the universe would see as happening at different times. Some of your nows are their pasts. Some of your nows are their futures. The present is not a universal layer slicing through reality. It is a personal, local, perspective-dependent thing. Your now is yours alone. But here is where it stops being a fun physics puzzle and starts being something genuinely unsettling. If your now is different from my now, if we can disagree about what is happening at this moment in a galaxy far away, then what does that mean for the past? If simultaneity is relative, then the past is also relative. Which means the question, has this event happened yet, doesn't have a single universal answer. It depends on who is asking and how fast they're moving. And now here is the line that changes everything. Physicist Heidegger published a paper in 1966. Philosopher Hilary Putnam independently reached the same conclusion in 1967. And the argument goes like this. Take two observers moving relative to each other. Call them you, and an alien on a planet in the Andromeda galaxy, 2.5 million light-years away. The alien is simply walking. Just strolling casually in a particular direction. Not flying. Not accelerating. Walking. Because of that motion, that gentle, ordinary walk, the alien's now slice through spacetime is tilted slightly relative to yours. Not by much. But across 2.5 million light-years, even a tiny tilt accumulates. And by the time you project that tilt all the way to Earth, the alien's now on Earth is not your now on Earth. Their present moment, on Earth, is hundreds of years in what you would call your past or your future, depending on which direction they walk. If the alien strolls toward the Milky Way, their present moment on Earth is in your future. Events that haven't happened yet for you are, right now, in their present. If the alien strolls away, their presence on Earth is in your past. Events you call history are, for them, currently happening. The alien isn't doing anything exotic. It's just walking. And the implication, the one that Heidegger and Putnam both landed on, is that if the alien's present includes what you call your future, then your future must already exist. It must be real. It must be there. Otherwise, it couldn't be there present. And if your future already exists, then the past definitely exists. Even more so. This argument has a name. It's called the Ryatic-Putnam argument. And it points directly toward the most radical idea in the philosophy of time. Imagine a loaf of bread. The whole loaf exists all at once, right? You can slice it anywhere. A slice near the left end. A slice near the right. A slice in the middle. Each slice is just a cross-section of the full, complete, already existing loaf. The loaf doesn't become the right end after it stops being the left end. All of it is there, simultaneously, waiting for wherever you choose to cut. Now replace the loaf with the universe. And replace the slices with moments in time. On this view, called the block universe, or eternalism, all of time exists simultaneously, the way all of space exists simultaneously. The universe is a four-dimensional structure, 3 dimensions of space, 1 dimension of time. And it's all just there. The year 1000 AD. The year 3000 AD. The Big Bang. Whatever comes at the end. All of it, laid out in one complete, unchanging, four-dimensional block. You are not moving through time. You are a four-dimensional object, a long, worm-like structure, that extends from your birth to your death, all of it already fixed in the geometry of space-time. What you experience as the present moment is just your consciousness located at a particular point along that worm. Like a flashlight sweeping across a painting. The painting doesn't change. The flashlight just moves. Einstein himself believed something very close to this. When his lifelong friend Michel Besso died in 1955, Einstein wrote a letter to the Besso family. He died himself 5 weeks later. In that letter, he wrote, "Now he has departed from this strange world a little ahead of me." That means nothing. For those of us who believe in physics, the distinction between past, present, and future is only a stubbornly persistent illusion. He wasn't being poetic. He was being precise. Now, the obvious objection. If all of time already exists, if the past is still there and the future is already fixed, then what are we doing? What is the point of choice? Of effort? Of anything? This is where people usually slam the door and walk away from the block universe. It feels like it kills free will. It feels like it turns life into a movie that's already been filmed, and we're just watching it play, under the illusion that we're making it up as we go. But hold on. Because the block universe doesn't actually say your choices don't matter. It says your choices are part of the fixed structure. The fact that you deliberated, wrestled, decided, that's also in the block. The block includes all the causation, all the reasoning, all the agonizing. It's not that your choices were bypassed. It's that your choices, and their consequences, are woven into the fabric permanently. Which is a different kind of strange. Your worst moment is in the block. Permanent. Real. But so is your best. So is every moment of love, every breakthrough, every quiet afternoon that felt like nothing and turned out to mean everything. None of it was erased. None of it was temporary in the way you feared. The block universe doesn't kill the meaning of your life. It preserves it. Perfectly. Forever. In four-dimensional amber. But here is where it gets even stranger. Because the block universe seems airtight. Seems inevitable given relativity. But then quantum mechanics walks in. And quantum mechanics does not knock. It kicks the door off the hinges. In 1978, physicist John Archibald Wheeler, one of the great minds of 20th century physics, the man who coined the term black hole, proposed an experiment so philosophically violent it should have come with a warning label. He called it the delayed choice experiment. Here is the setup. Light, as you may know, has a split personality. Sometimes it behaves like a wave, spreading out, interfering with itself, creating ripple patterns. Sometimes it behaves like a particle, a single discrete bullet, hitting one spot and one spot only. For most of the 20th century, physicists assumed that which behavior you got depended on how the experiment was set up before the light was released. Set up a wave detector, you get wave behavior. Set up a particle detector, you get particle behavior. The light, presumably, made its decision at the start of the journey. Wheeler asked, "What if you wait? What if you send the light through the apparatus, down its long journey toward the detector, and then, at the last possible nanosecond, before it arrives but after it's already been traveling, you choose which kind of detector to use? You'd expect it wouldn't matter. The light already made its decision at the beginning. It's been a wave or a particle for the entire trip. You're just finding out which. But that is not what happens. The light, and this has been experimentally confirmed, repeatedly, in labs around the world, behaves as if it retroactively adjusts its behavior to match the detector you chose after it was already traveling. Choose a wave detector at the last moment. The light behaves as though it was always a wave, going all the way back to the source. Choose a particle detector. The light behaves as though it was always a particle, the entire journey. It doesn't matter if the journey took a nanosecond. Or, in the most extreme version of the experiment, using light from distant quasars as the source, it doesn't matter if the journey took billions of years. A team of astronomers in 2017 ran this experiment using quasars as photon sources. Light that had been traveling for 7 to 10 billion years. And the choice made now, in a lab, about what detector to use, seemed to determine what that light had been doing for billions of years before the choice was made. The present appears to reach back and shape the past. Not the future. The past. Now. Before your brain fully melts, physicists argue about what this means. There are interpretations of quantum mechanics that explain this without literal backwards causation. The many worlds interpretation, for instance, says all outcomes happen in branching parallel realities, and no single timeline is retroactively altered. The Copenhagen interpretation says the photon simply didn't have a definite state until measurement, so there's nothing to rewrite. But here is what every single interpretation agrees on. The past, at the quantum level, is not a fixed, fully determined record. Whether it's because the past is literally being rewritten, or because it was never fully written in the first place, either way, the simple picture of a solid, locked, immovable past turns out to be wrong. The past is weirder than we thought. More fluid. More entangled with the present. In some interpretations, more alive. Wheeler had a phrase for this. He believed the universe was not just observed, he believed it was participatory. That conscious observation, choices made in the present, played a role in constructing the reality of the past. He called it the participatory universe. He drew a picture of it once. A giant U-shape. One end is the Big Bang. The other end is a human eye, looking back. And in Wheeler's universe, that human eye, you, looking at an ancient photon, is not a passive recorder. You are, in some sense, completing the past. Every time you observe something, you are casting a vote on what the universe was. That is either the most empowering idea you've ever heard, or the most terrifying. Possibly both. And we haven't even gotten to entropy yet. Or black holes. Or the possibility that the universe has been keeping a perfect record of everything that has ever happened, every thought, every action, every moment, written into the fabric of reality itself, in a language we are only just beginning to learn to read. Because here is the thing. The past might still exist. The past might be editable. And the universe might have a memory. Which raises a question nobody is prepared for. If the universe remembers everything, what, exactly, does it remember about you? Here is a magic trick. exactly the same equations whether you film it forward or backward. There is nothing in the fundamental things tend to go from order to disorder, from concentrated to spread out. Scratches on wood, emotional scars, chemical traces. The future order toward the eventual maximum disorder that physicists call the heat death, a future state entropy in some small region. Ice forming in a warm room. A broken cup reassembly. But he spent his life staring directly into one of the deepest mysteries in physics and never looked away. In 1974, Stephen Hawking did something extraordinary and, from a certain angle, incredibly inconvenient. He proved that black holes evaporate. Black holes, these supposedly perfect cosmic prisons, regions of spacetime so warped that not even light can escape, Hawking showed they slowly bleed energy. Quantum effects near the event horizon cause pairs of particles to pop into existence from the vacuum. One particle falls in. One escapes. Over time, the black hole radiates, shrinks, and eventually, after an almost incomprehensibly long time, disappears entirely. This is Hawking radiation. And it won Hawking enormous fame and, among physicists, an almost immediate headache. Because here was the problem. Hawking radiation, as originally calculated, is thermal. Random. It carries no information about what fell into the black hole. A black hole could swallow a book, a human being, an entire civilization, and the radiation it eventually emits would be pure noise. No signal. No structure. No record. The information would be gone. Destroyed. Not scrambled, not hidden, annihilated. And this is a catastrophe. Not metaphorically. Technically. Because quantum mechanics has a rule. A deep, foundational, non-negotiable rule. It is called unitarity. And unitarity says that information is never destroyed. Ever. The total information content of the universe is conserved. You can scramble information, spread it out, hide it in the correlations between a trillion particles, but you cannot erase it. The equations do not allow deletion. Hawking's calculation said, black holes erase information. Quantum mechanics said, nothing erases information. They could not both be right. This became known as the black hole information paradox. And for 30 years, it was one of the most vicious, productive, wonderful arguments in theoretical physics. Hawking himself spent decades defending his original result. He bet an encyclopedia against John Preskill that information was destroyed. He eventually conceded. Sort of. Grudgingly. The resolution, still not fully agreed upon, still actively debated, points somewhere extraordinary. The leading candidate answer involves something called the holographic principle. And the holographic principle is one of those ideas that sounds like science fiction until you realize that some of the most careful physicists alive think it might be literally, exactly true. Here is the idea. You know what a hologram is. A flat, two-dimensional surface that encodes a three-dimensional image. You look at it from different angles and you see depth, structure, volume, all encoded in the flat surface. The holographic principle, proposed by Gerard T. Hooft and Leonard Susskind in the 1990s, suggests that our universe works the same way. All of the information contained in a volume of space, everything that is happening in a three-dimensional region, is completely encoded on the two-dimensional boundary of that region. Like a hologram. Like the entire content of a room being secretly written on the walls. In the context of black holes, everything that ever fell into a black hole is encoded on its event horizon. The two-dimensional surface of the black hole. And as the black hole slowly evaporates via Hawking radiation, it doesn't destroy that information. It encodes it in the outgoing radiation, scrambled, hidden, extraordinarily difficult to read, but there. All of it. Perfectly preserved. Nothing goes in and gets erased. Everything that goes in gets written onto the surface and slowly, carefully, chaotically released. Now extend this. If the holographic principle applies to black holes, some physicists argue, it may apply to the universe itself. The universe may have a boundary, a cosmic horizon beyond which nothing can communicate with us. And on that boundary, encoded in some form we cannot yet read, may be the complete information content of everything that has ever happened inside. Every conversation. Every explosion. Every collision of particles since the first microseconds after the Big Bang. Every living thing. Every decision. Every moment that felt like it vanished into nothing. All of it, still there. Written in the most permanent ink the universe has. This is not established physics. This is the frontier, the edge of what we know, where the equations start to get tentative and the debates get loud. But it is not fringe speculation either. It is where the serious people with the hard mathematics are spending their careers. Because unitarity keeps insisting. Information is conserved. The universe keeps receipts. Juan Meldacena, in 1997, published what became one of the most cited papers in the history of theoretical physics. It describes something called the AD/CFT correspondence, a mathematical duality showing that a theory of gravity in a certain kind of curved space is exactly equivalent to a quantum field theory on the lower dimensional boundary of that space. You don't need to understand the technical details. What matters is the implication. Meldacena showed, with extraordinary mathematical precision, that there exists a description of reality in which everything happening in three-dimensional space is completely, perfectly, and without loss encoded in a two-dimensional theory on the boundary. No information is lost. Not in principle. Not anywhere. The universe is, on this view, not just preserving the effects of the past, not just leaving ripples and records and scars. It is preserving the complete, exact, total informational content of every event that has ever occurred. The past is not just geometrically real, as Einstein's relativity suggests. It is informationally immortal, as quantum mechanics insists. Here is a way to feel that concretely. Right now, in your body, there are roughly 7 billion atoms. That is a 7 followed by 27 zeros. Each one of those atoms has a history that goes all the way back to the beginning of the universe. The carbon in your bones was forged in the cores of ancient stars that exploded billions of years before you were born. The hydrogen in your water is almost as old as time itself, created in the first few minutes after the Big Bang. Those atoms carry information. They are in specific quantum states, with specific correlations, with specific histories encoded in their configurations. When you die, and here is the part people do not sit with long enough, those atoms do not vanish. They disperse. They go into the ground, the air, other living things. The information they carry becomes fantastically, almost impossibly scrambled and spread across the environment. But scrambled is not erased. In principle, deep in principle, buried under layers of crushing computational impossibility, the information about every atom that ever made up you, every interaction you ever had, every moment of your life that left a physical trace, is still in the universe. Distributed. Hidden. Encoded in correlations between particles scattered across continents, oceans, eventually stars. The universe, in this sense, has not forgotten you. It cannot. The laws of quantum mechanics will not allow it. There is a physicist named Charles Bennett, who worked at IBM and spent decades thinking about information theory, who puts it something like this: the universe is like a vast, perfect book in which every event is written. The writing gets scrambled, compressed, distributed across an unimaginable number of pages, but it is never torn out. Nothing is deleted. Only hidden. And here is the line that turns this from physics into something that keeps you awake. If the information about every event is preserved, if the universe truly keeps perfect records, then somewhere in the structure of reality, the information about every moment of your life is still intact. The afternoon you've been trying to remember. The face of someone you've lost. The exact texture of a moment that mattered more than you knew at the time. Not as memory. As physics. Not in the mind's imperfect, fading, reconstructive memory, but in the cold, perfect, indelible record of particle correlations and quantum states that the universe is legally, physically, mathematically forbidden from destroying. The past is not gone. The past is encoded. But there is one more question. The one that brings all of this together and pushes it somewhere no equation can fully follow. We have been talking about the past in terms of geometry, in terms of information, in terms of thermodynamics. In terms of what the universe remembers and why. But there is a version of this question that is harder. Closer. More personal. If the past still exists as a geometric fact of spacetime, if the block universe is real, then every moment of your life is still happening. Not as information. Not as a record. As a live, continuous, fully real event, located at a specific address in four-dimensional spacetime. The child you were is not a memory. That child is still there, in a direction you cannot travel, living that moment as fully and completely as you are living this one. The person you loved who is gone, they are not gone in the geometry of the universe. They exist at their coordinates in spacetime. A specific location. A real address. Unreachable, yes. But there. And that raises something that no physicist's equation can handle alone. Something that requires philosophy, and maybe something beyond philosophy. If every moment of your life still exists, if you are a four-dimensional object, your entire history laid out like a landscape in spacetime, then what are you? Which moment is the real you? Are you the child, still existing in their moment? The person you are now, reading this? The person you will be in 10 years, already fixed in the geometry of a future you cannot yet see? Or are you all of them, simultaneously, a long thread of consciousness stitched through spacetime, each version equally real, each moment equally alive, each version of you as present and complete as any other? The block universe doesn't just preserve the past. It preserves you. All of you. Every version. Every moment. Nothing you have ever lived through has been erased. Every laugh. Every failure. Every ordinary Tuesday morning that felt like nothing. Every last second of every relationship you have ever had. It is all still there. In the geometry of spacetime, in the information encoded in the fabric of the universe, in the perfect ledger that quantum mechanics says cannot be destroyed. The past is not over. The past is not behind you. The past is the most permanent thing in existence. And that changes what it means to ask, who are you? Let's stop talking about photons for a moment. Let's talk about you. Not you as a collection of atoms. Not you as a pattern of information encoded in quantum states. Not you as a four-dimensional worm in spacetime, which is technically what the block universe says you are, and which is technically correct, but which is not the kind of thing you lead with at dinner parties. Let's talk about you as the thing you actually experience yourself as. A person. Someone who wakes up in the morning with a specific weight of history behind them. Someone who has lost things. Someone who carries moments around that refuse to leave, and chases moments that refuse to stay. Because the physics we have been building, layer by layer, section by section, is not just an abstract curiosity. It is not just something to feel clever about. When you take it seriously, when you let it actually land, it does something to the way grief feels. To the way memory feels. To the way you relate to the people who are no longer here, and the person you used to be, and the moments that felt, that still feel, like the most important things that ever happened to you. So let's take it seriously. Let's let it land. Start with loss. Someone you loved is gone. Maybe recently. Maybe long ago. The specific ache of that kind of loss has a particular quality that is different from other kinds of pain. It is not just sadness. It is a spatial disorientation. A sense that something has been removed from the world, that the world has a hole in it where a person used to be. You reach for them in the structure of reality and your hand passes through empty air. They are gone, your nervous system says. They no longer exist. The relationship is over not because it ended but because one half of it ceased to be. Now hold that feeling. Hold it right there. And now bring in the block universe. If eternalism is correct, and remember, this is not philosophy invented to make people feel better, this is the geometric implication of special relativity, one of the most tested theories in human history, then the person you lost is not gone from the universe. They are gone from your present. Which is a completely different thing. Their coordinates in spacetime are fixed. Their moments are real. Every conversation you ever had with them is still happening, right now, at its address in four-dimensional spacetime. Every meal. Every ordinary exchange that you didn't know you were memorizing. Every moment of them being fully, completely, irreducibly themselves. In the geometry of the universe, they are not absent. They are located. Unreachable? Yes. Separated from you by a distance in time that you have no engine to cross? Yes. But present. Real. Not a memory, a fact. Now. This is not consolation theology. This is not someone telling you a pretty story to make the pain go away. The pain doesn't go away. The absence in your daily life is real, and it is brutal, and no amount of physics changes the fact that they are not sitting across from you right now. But there is a difference, a genuine, substantive difference, between a universe in which the people you have lost are annihilated, erased, reduced to nothing, and a universe in which they exist at permanent coordinates in a four-dimensional structure, their moments intact, their existence geometrically real, their presence woven into the fabric of what has happened. One of those universes is colder than the other. And physics, at least tentatively, at least on the current best reading of our deepest equations, seems to suggest we live in the warmer one. Now let's talk about regret. Regret is a specific kind of relationship with the past. It assumes a particular model of time, the one that says the past is gone, that moments are spent and cannot be recovered, that choices made poorly are simply waste, gone into the void. Regret is the feeling of loss about something that can no longer be changed, in a universe where things that are over are simply over. But if the past is geometrically real, if the block universe is right, then your worst moment is not gone. It is still there, permanent, at its address in spacetime. And before you say, "That sounds worse," wait. Because that permanence cuts both ways. Yes, your worst moment is still there. Still happening, at its location in the four-dimensional structure. The thing you said that you can't unsay. The thing you didn't do when you could have. The person you didn't call. It's all in the block. Fixed. But here is what that also means. Your best moment is in there with equal permanence. The moment you came through something that should have broken you. The time you helped someone when it cost you something to do it. The afternoon that was so good, so quietly perfect, that you knew even while it was happening that you were going to miss it. The moment someone looked at you and you felt, for one clean second, completely understood. All of it is in the block. All of it is geometrically real. All of it exists with the same permanence, the same ontological weight, the same unchangeable reality as the physics of a star or the orbit of a planet. Your best moments are not fading. They are not becoming less real as they move into the past. In the block universe, they are exactly as real as they were when you lived them. Exactly as present. Exactly as fully happening. The past does not dilute. It does not erode. It does not fade in the way memory fades. In the geometry of spacetime, things that have happened are more permanent than things that are happening now. Your present moment is fleeting, here, then gone to the past. But the past, on the block universe view, is already set, already fixed, already beyond the reach of change. Which means it is also beyond the reach of loss. Here is a thought experiment. A simple one. Imagine your life as a novel. Not the experience of reading it. The experience of reading is sequential, a word at a time, a page at a time, building through time. But the novel itself, the physical object. The first chapter does not cease to exist when you turn to the second chapter. Chapter 1 is still there, in the book, whether you are reading it or not. The events of Chapter 1 are not erased by the progression to Chapter 2. They are part of the permanent structure of the book. Now ask, does the protagonist of Chapter 1 still exist? In one sense, no. They are a child, or younger, or in different circumstances. The person you meet in Chapter 25 is different. Grown, changed, marked by what Chapter 1 set in motion. But in another sense, in the sense of the actual physical novel, the complete and finished object, yes. That version of the protagonist is right there. In the book. On those pages. As real as any other version. On the block universe reading of physics, your life is that novel. And every chapter is still in the book. The you at age 7 is still on those pages. The you at your lowest point is still there. The you on the best day you can remember is still there. Not as echoes. Not as memories. As fully real events, in the permanent structure of spacetime. The question that this raises is one of the strangest in philosophy, and we should not rush past it. Which moment is you? This is the hard question. The one that the physics opens up and then declines to answer. If all your moments are equally real, if the 7-year-old and the 40-year-old and the version of you that hasn't been born yet are all just different addresses on the same four-dimensional object, then what exactly are you? What is the self? You experience yourself as a continuous thread. A single perspective that moves through time, collecting experience, accumulating memory, changing gradually from moment to moment while retaining some sense of being the same entity throughout. But the block universe complicates that. Because in the block universe, you are not moving. The experience of moving through time is, on this view, something that happens within a static structure. The four-dimensional object that is your life does not travel through spacetime. It is simply in spacetime. All of it, at once, already. What you call moving forward in time is just your consciousness located at successive points along that object. Like reading successive words in a sentence that is already fully written. And if that is true, if you are a four-dimensional object and not a moving point, then the question, which moment is the real you, has a strange answer. All of them. Simultaneously. Every version of you, from birth to death, every day in between, is equally the real you. Equally present. Equally happening. The version reading this sentence is not more real than the version that will read the last word of the script. The version you were at your most broken is not less real than the version you were at your most whole. You are all of it, always, at once, in the four-dimensional structure of spacetime. Which is either the most liberating idea you have ever encountered, or the most vertiginous. Probably both. Now let's go one layer deeper. Because there is a version of this conversation that gets personal in a way that pure physics cannot quite reach. Think about identity. Specifically, think about the person you were 10 years ago. Are you the same person? In one obvious sense, yes. You have legal continuity. The same name. The same body, more or less, though most of the atoms have been replaced. The same general stream of memory connecting that past self to this present one. But in another sense, in the sense that most matters, the sense of how you actually think, what you actually value, what you actually feel when you lie awake at 3 a.m., you might be quite different. The person you were 10 years ago might have believed things you no longer believe. Wanted things you no longer want. Been afraid of things that no longer frighten you, and unbothered by things that now keep you up at night. How much of that older self is still you? Philosophers call this the problem of personal identity over time. And it is ancient. Theseus's ship, if you replace every plank of a ship, one by one, until none of the original material remains, is it still the same ship? And if not, at which plank did it stop being the original? You are Theseus's ship. Your atoms are almost entirely replaced every several years. Your beliefs, values, fears, and desires shift continuously. The thread of memory connecting your past self to your present self is imperfect. You misremember, reinterpret, reconstruct. Memory is not a recording. It is a story you tell yourself, and the story changes with each telling. So who are you, exactly? The block universe offers a strange answer. You are the entire four-dimensional object. The whole thing. You are not the ship at any particular moment of plank replacement. You are the complete history of the ship, from launch to harbor, every version at every moment, the full trajectory through spacetime. Your identity is not located at a point. It is the shape of the trajectory. The specific path you carve through spacetime, the unique, unrepeatable sequence of moments, relationships, decisions, and experiences that constitutes your existence, that is you. Not any single moment of it. The whole curve. And that curve, once it exists, is permanent. Unchangeable. Geometrically real in the four-dimensional structure of the universe. You are writing it now. Right now, in this moment, you are adding coordinates to the trajectory. Shaping the curve. Deciding, or appearing to decide, in your experienced present, what the next point will be. And once it is written, it is written. Not as text that can be erased. As geometry that cannot. There is a philosopher named Derek Parfit who spent his career thinking about personal identity and time, and who arrived, through pure philosophical reasoning with no physics at all, at something remarkably close to the block universe conclusion. Parfit argued that the self is not a single, solid, persisting entity. It is a series of connected psychological states, linked by memory and continuity, but not amounting to anything more metaphysically substantial than that. There is no deep self, no soul-like essence, that persists through time and makes you you. There is just the chain of states. The trajectory. And when Parfit reached that conclusion, he expected to feel disturbed. Instead, he reported something unexpected. He felt liberated. Because if there is no fixed, essential self that must be protected and preserved at all costs, if you are a trajectory rather than a thing, then the boundaries of the self become more porous. Less defended. Less anxious. You are not a fortress that must hold against time. You are a river that has already flowed, and is flowing, and will flow, and the flowing is the thing, not the preservation. Parfit wrote, "My life seemed like a glass tunnel, through which I was moving faster every year, and at the end of which there was darkness. Within this tunnel, each thing seemed to matter. I seemed to have an important conversation with myself about my future. Then I changed my view. I seemed to have escaped from a glass tunnel." He escaped the tunnel by realizing the self was not as fixed, as bounded, as isolated as he had assumed. The block universe, strangely, reaches the same escape route from a completely different direction. You are not a glass tunnel, moving toward darkness. You are a shape in spacetime, completely and permanently real at every point, from beginning to end, all of it already there. Now here is the implication that nobody talks about enough. If you take the block universe seriously, if every moment of your life is equally real, equally permanent, equally existent, then the moments that felt like nothing might matter more than you think. Here is what I mean. You remember the big moments. The turning points. The losses, the breakthroughs, the watershed experiences that divided your life into before and after. Those are the ones you can name, the ones that feel like they constitute the narrative. But most of your life is not those moments. Most of your life is the Tuesday afternoon you've completely forgotten. The Wednesday morning. The ordinary lunch, the unremarkable commute, the quiet hour before bed when nothing seemed to be happening. Most of your moments, if you are honest, felt like they were just passing time on the way to something more important. But if all moments are equally real, if Tuesday afternoon has the same ontological weight as your greatest triumph, then the moments you dismissed as nothing were not nothing. They were your life. The low entropy, ordinary, passing moments that felt like filler. The Tuesday you barely remember. The conversation you didn't think was important. The quiet evening that felt like a placeholder. All of it equally permanent. All of it equally real. All of it in the block. There is no filler. There is no waiting for the important parts. There is no moment that was merely passing time. Every moment is fully in the block the instant it happens, and it stays there forever. That is either a comfort or a challenge. Probably both. And now, from the personal, let's go back out to the cosmic. Because there is a question that the block universe and the holographic principle and the conservation of information all point toward, together, in unison, like a choir singing the same note from different directions. If every moment is real. If information is never destroyed. If the past is geometrically permanent and informationally immortal and potentially observable by a sufficiently advanced intelligence with access to the right boundary conditions. Then what is the status of a moment that no one witnessed? If a tree falls in a forest and no one is there to hear it, does it make a sound? The old question. The annoying question. The question you've heard used as a punchline. But in the context of everything we have been building, it is not annoying at all. It is one of the most important questions in physics. Does an unobserved event have a definite past? Quantum mechanics, before measurement, says, not necessarily. The wave function of an unobserved system evolves as a superposition of possibilities, not a single definite history. The act of observation is what collapses those possibilities into a specific, definite event. But then, what happened before there were observers? What is the status of the first 380,000 years of the universe, before light could travel freely, before anything like an observer existed? What is the status of the billions of years of cosmic history before life emerged? Before anything was there to see it? Was the universe in superposition the whole time? Was it writing its own history in some kind of indefinite, unresolved quantum blur until life evolved and started observing? Wheeler thought so. Wheeler believed, genuinely, that observers are not just passive recorders of cosmic history. They are, in some sense, participants in creating it. That the universe's past is not simply there, fixed and definite, waiting to be discovered. It is, in part, constructed retroactively by the act of observation. He went further. He speculated, and this is well past the edge of established science, but it is worth hearing because of who said it, that the universe requires observers to exist. Not because observers create the physical matter, but because the physical events of the past require observation to become definite, to become real in the fullest sense. And if that is right, if observers participate in crystallizing the past, then your existence is not just a product of cosmic history. Your existence, in some strange, partial, deeply mysterious way, is a participant in creating cosmic history. Every time you observe something, every time you receive a photon from an ancient star, every time you measure anything, every time your consciousness interacts with the quantum world, you are doing something to the past. Not changing it, exactly. Completing it. Closing possibilities down into actualities. Making indefinite things definite. You are not just a witness to the universe. You are, in Wheeler's strange and serious vision, one of the things that makes the universe real. Here There is something physics keeps walking up to and then quietly stepping around. It will derive the equations of time. It will describe time's geometry, its thermodynamic arrow, its relativistic flexibility, its quantum ambiguity. It will tell you that time is a dimension, or that time is emergent, or that time is an illusion, or that time is the most real thing in the universe, depending on which physicist you ask and what mood they are in. What it will not do, what it has never done, in 300 years of extraordinary progress, is explain why time feels the way it does. Not the arrow. Not the geometry. The feeling. The feeling of now. Right now, this specific, irreducible, present moment, you are experiencing something that has no name in the equations. Something that every human who has ever lived has experienced and that no physical theory has ever fully captured. The feeling of being here. In this moment. Not in the past, not in the future, but right now, at this specific point, with this specific quality of presence. Philosophers call it the specious present. The felt now. The thin, bright edge of experience that separates what has happened from what is about to happen. The moment you are always in, that is always moving, that you can never step outside of and examine. Physics can tell you that the present moment, globally speaking, doesn't exist. It can tell you that now is a local, observer-dependent concept with no universal meaning. It can tell you that the experience of time flowing is a product of entropy and neural processing, a story your brain tells itself about the sequence of its own states. What it cannot tell you is why any of that feels like anything. Why is there a felt quality to the present moment? Why is there something it is like to be here, now, in this moment? Why doesn't the processing of temporal information simply happen in the dark, mechanically, the way a clock measures time, without any felt quality, without any experience of nowness? This is a version of what philosopher David Chalmers called the hard problem of consciousness. Not the easy problems. How does the brain process information? How does it integrate sensory data? How does it produce behavior? But the hard one. Why does any of it feel like anything? Why is there subjective experience at all? And the hard problem of time is its quieter sibling. Not just why is there consciousness, but why does consciousness feel embedded in a flowing present? Why does time feel like it moves? Why does the now feel like now? Here is how deep the problem goes. Your brain processes information in time. Neural signals take time to travel. Different regions of the brain receive information at slightly different moments. When you see a flash of light and hear a simultaneous sound, your brain has to actively synchronize those signals. They arrive at different times, through different pathways, at different speeds, and construct the experience of them happening together. The now you experience is already a construction. Already a product of neural computation. The felt present is not the actual present, it is a slightly delayed, heavily processed, actively constructed narrative of what just happened, presented to you as if it were happening right now. Neuroscientist Benjamin Libet's famous experiments in the 1980s made this horribly concrete. He found that the brain initiates certain movements about half a second before the person becomes consciously aware of deciding to move. The decision, the felt, experienced, conscious choice, comes after the brain has already begun to act. Your felt present is, neurologically speaking, already the past. The now you are experiencing right now is a reconstruction of events that already occurred in your brain, presented to you with a timestamp that says, this is happening now, when in fact it happened a fraction of a second ago. Your experienced present is a memory of the very recent past, dressed up as the current moment. So the experienced now is not even real in the most immediate physical sense. And yet it is the most real thing you have ever encountered. More real than any theory. More real than any equation. The sheer undeniable fact of being here, in this moment, experiencing something, this is the one thing you cannot doubt. Descartes tried to doubt everything and found he could not doubt the existence of the doubter. The experience of now, whatever its neural underpinnings, whatever its relationship to physical time, is the bedrock of everything. And physics floats above it, describing the structure of time with extraordinary precision, while leaving untouched the most immediate fact of your existence. This is not a failure of physics. It is a boundary. The edge of what the current framework can reach. And standing at that edge and looking down is one of the most vertiginous experiences available to a thinking person. Because here is what it implies. Every physical theory of time, block universe, presentism, the thermodynamic arrow, quantum gravity, is a theory about the structure of time. About its geometry, its statistics, its information content. These theories are describing something from the outside. They are maps of the territory. But you do not experience time from the outside. You experience it from the inside. From the only vantage point that has ever existed for you. From the felt, irreducible, first-person perspective of a conscious being embedded in a flowing present. And that first-person experience, the experience that time is flowing, that now is special, that the past is behind you and the future is ahead, is not explained by any of the maps. The maps say the flow is an illusion. The maps say now is not special. The maps say the past and future are equally real locations in a four-dimensional structure. But the experience says, now is all there is. Now is everything. Now is the only place you have ever been. Which one do you trust? The physicist Lee Smolin has spent decades arguing for a position almost no one else in theoretical physics takes, that time is real. Fundamentally, irreducibly real. Not emergent, not illusory, not a dimension in a block, but the most real thing in the universe. The one thing that is more fundamental than the laws of physics themselves. Smolin argues that the laws of physics are not fixed, eternal, timeless truths hanging in a platonic void somewhere outside the universe. The laws of physics evolved. They changed. They are products of a universe that has a genuine history, in which time moves forward and things actually happen and the past is genuinely different from the future. On Smolin's view, the block universe is not just philosophically uncomfortable, it is physically wrong. The future is genuinely open. Not just epistemically uncertain, ontologically unreal. It does not exist yet. It will be created, moment by moment, by the genuine forward progression of physical time. And the past, on this view, is also genuinely gone. Not located. Gone. Smolin's view is a minority position. Most physicists who think carefully about it lean toward some form of eternalism, pushed there by the implications of relativity. But Smolin is not a crank. He is one of the most serious and original thinkers in the foundations of physics. And his argument deserves to be heard. Because it says something important. It says, maybe the experience of time is not an illusion that physics has exposed. Maybe the experience of time is data that physics has not yet successfully incorporated. Maybe the felt flow of time, the irreducible nowness of the present moment, the genuine openness of the future, maybe these are not mistakes your brain is making. Maybe they are features of the universe that our current theories are too incomplete to capture. Maybe the hard problem of time is hard not because consciousness is confused, but because physics is incomplete. In the 1960s, two physicists named John Wheeler and Bryce DeWitt tried to do something no one had succeeded at before, or since. They tried to write down the quantum mechanical equation for the universe. Not for a particle. Not for a field. For the entire universe, as a single quantum system. And when they wrote it down, when they combined the framework of quantum mechanics with the framework of general relativity, as carefully and rigorously as they could, they got something that should have generated enormous headlines and caused at least 3 existential crises per physics department. The equation they got had no time in it. The Wheeler-DeWitt equation, still one of the central equations in quantum cosmology, still argued about, still not fully solved, describes the quantum state of the universe. And the quantum state of the universe, according to this equation, does not evolve in time. It does not change. It does not develop. It sits in a single, static, timeless configuration. Time does not appear in the equation at all. Let that fully settle. The equation that is supposed to describe everything, the entire universe as a quantum system, has no time variable. Not because time was forgotten. Not because someone made an error. Because when you try to write down the quantum mechanics of the universe, including gravity, time cancels out. It drops out of the equation. It vanishes. And this is not a minor technical issue. This is a crisis at the center of theoretical physics. It is called the problem of time in quantum gravity. And it has been sitting there, unresolved, since Wheeler and DeWitt first stared at their equation and realized what they had. The problem goes like this. In quantum mechanics, things evolve in time. The wave function changes from moment to moment, governed by the Schrödinger equation. Time is the parameter that the evolution happens against. It is the background. In general relativity, time is not a background. Time is part of the dynamical structure of spacetime. It is affected by matter and energy. It bends and stretches. It is part of what the theory is describing, not a fixed stage on which the description happens. When you try to combine the two, when you try to write quantum mechanics on a dynamical spacetime, without a fixed time background, the equation you get has no place for time at all. The universe, at the deepest level of the most complete theory we can currently write down, appears to be timeless. So where does time come from? This is the question. And the leading candidate answer is one of the most beautiful and strange ideas in modern physics. Time, on this view, is not fundamental. It is emergent. It arises from the entanglement between different parts of the universe. The idea was developed in a serious form by physicists Page and Wouters in the 1980s and has been formalized and extended since. Here is the rough shape of it. The universe is a quantum system in a timeless state. But it is not a simple system. It is an enormously complex system with many parts, all quantum mechanically entangled with each other. And when you look at one part of the system, say, a clock, from the perspective of another part of the system, say, an observer, the correlations between them give the appearance of time. The clock and the observer are entangled. The state of the observer is correlated with the state of the clock. And as you trace through the different values the clock can have, you find that the state of the observer changes, evolves, as if time is passing. But no time is passing. The total state of the universe is frozen. It is the relationship between parts of the universe, the entanglement, that generates the experience of temporal evolution. An experiment in 2013, by Moriva and collaborators, tested a toy version of this idea in a lab. They created a simple quantum system with two entangled photons. From the perspective of an external observer, someone outside the system was static, timeless. From the perspective of an internal observer, one of the photons observing the other, time appeared to flow. The internal clock ticked, even though from outside, nothing moved. Time is not something the universe is inside of. Time is something that happens between parts of the universe, from the inside. If this is right, and it is a serious research program, not a settled result, then the question of whether the past exists takes on yet another layer. Because if time is emergent, if it arises from entanglement between subsystems, then asking whether the past exists is like asking whether a wave exists when the ocean is frozen. The past is a feature of a certain kind of description, a certain level of analysis. At the deepest level, where the Wheeler-DeWitt equation lives, there is no past or future. There is only the timeless quantum state of everything. The past is not preserved in that picture. The past is not destroyed in that picture. The past simply does not apply to that picture. It is like asking whether a song is loud or quiet, and someone telling you, at the level of fundamental physics, there is no sound. There are only air molecules and their positions. Loudness is a concept that emerges at a higher level of description, and it doesn't translate down. The past might be like loudness. Real and meaningful at the level of description where we live, the level of observers, of entropy, of records, of memory. But not a feature of the deepest basement of reality. Which does not mean it isn't real. Loudness is real. Your experience of a piece of music is real. The fact that it emerges from air molecules rather than being built into the fundamental equations does not make it less real. It makes it more interesting. Because it means reality has levels. And the level we live at, the level of time, of before and after, of past and future, of memory and anticipation, is not a confused, imperfect shadow of the deeper timeless reality. It is a genuine level of description, with its own real features, its own structures, its own truths. The past is real at our level. Completely, fully real. Even if, at the deepest level, the concept dissolves into something stranger. Here is a different kind of problem. We have been assuming, throughout everything we have said, that there is one past. One history. One sequence of events that led to this moment. Quantum mechanics, in its most straightforward interpretation, disagrees. The many worlds interpretation, developed by Hugh Everett in 1957, ignored for 20 years, now one of the most discussed interpretations among physicists who think seriously about quantum foundations, says this. The wave function never collapses. Every time a quantum measurement is made, every time a quantum event with multiple possible outcomes occurs, the universe does not pick one outcome. It branches. Every possible outcome happens, in a separate branch of the wave function, equally real, equally physical, equally existing. The cat is not alive or dead when you open the box. The cat is alive in one branch and dead in another, and both branches are equally real, and in both branches there is a version of you opening the box and seeing the result. Every quantum event, and quantum events are happening constantly, at every scale, in every cubic centimeter of the universe, generates a branching. An explosion of new branches, each containing a fully real, fully physical, fully inhabited version of reality. The number of branches is not 2. It is not 1,000,000,000,000. It is a number so incomprehensibly vast that it makes the number of atoms in the observable universe look like a rounding error. Now ask, in this picture, what is the past? In your branch, the past is the sequence of events that led, through a specific series of quantum branchings, to this specific moment. Your past is the particular path through the branching tree that ended at you, here, now. But at every branch point, at every quantum event in your history, there is another branch where things went differently. A branch where the photon hit the left detector instead of the right. A branch where the radioactive atom decayed a microsecond earlier. A branch where the random quantum fluctuation in a neuron in someone's brain went the other way, and they said something different, and your life went a different direction. There is no unique past. There is a vast, incomprehensibly branching tree of pasts, all equally real, all equally physical, all containing a version of the universe that is exactly as concrete as this one. Every decision point in your life, and I mean this in the most literal, physical sense, generated a branching. In some branches, the version of you who exists right now made different choices, had different experiences, became a different person. Those versions are not hypothetical. On the many worlds view, they are as real as you are. Your past is not one story. It is one branch of an incomprehensibly large tree, and every branch is equally real. The implication for our central question is vertiginous. If the past still exists, and we have made a long, careful argument that it does, then it does not just exist as your past. It exists as every branch. Every version of events that could have occurred, did occur, somewhere in the branching structure of the universal wave function. The version of your past in which the key conversation went differently, it exists. Not as a possibility. Not as a counterfactual. As a real, physical, fully inhabited branch of reality. The version of history in which the crucial decisions went the other way, it exists. There are versions of the past in which everything you think of as your life never happened. In which the particular chain of events that produced you, specifically, was broken at some link, and someone else exists at these coordinates, living a life you will never know. Those versions are all in the block. All geometrically real. All informationally preserved. The past is not just bigger than we thought. It is wider than we thought. It branches, and every branch is real, and all of it persists. This does something interesting to regret. The The thing you regret, the choice you made, the thing you said, the path you took, produced this version of you, in this branch. But in another branch, the other choice was made. The other path was taken. And that branch is also real. On the many worlds view, you did not fail to take the other path. You are the version of the branching that took this path. Another version of you took the other one. Both outcomes are in the block. Both are real. This is not licensed to be careless. The version of you in this branch still lives the consequences of this branch's choices. The fact that another branch exists where things went differently doesn't make the consequences in your branch less real. But it does change the existential weight of the alternatives. The road not taken was not lost. It was taken. In another branch. By another version of you who is, right now, at their own present moment, living the consequences of that choice, and perhaps looking back with their own regrets about the path that led to you. The multiverse does not eliminate regret. It does something stranger to it. It makes regret redundant. Everything that could have happened, happened. Somewhere. In some branch. You are not the sum of your choices, you are one branch of a vast choosing. The other branches exist, equally real, equally valid, equally in the permanent structure of the universe. You are, in a sense, all your possible selves, simultaneously, across branches. The one who made the call, and the one who didn't. The one who stayed, and the one who left. The one who spoke, and the one who stayed silent. All of them are in the block. All of them are real. Now let's go somewhere that sounds like science fiction but which serious philosophers at serious institutions argue about in serious journals. What if the universe is computational? Not as a metaphor. As a literal, physical hypothesis. The simulation argument, most associated with philosopher Nick Bostrom at Oxford, goes like this. In the future, assuming civilization continues and technology advances, it seems plausible that sufficiently advanced civilizations would develop the ability to run detailed simulations of reality. Not just video games. Not just virtual environments. But complete, physics-accurate simulations of entire universes, down to the quantum level, including all the complexity, all the relationships, all the experiences of the beings inside. If that is possible, then civilizations would probably run many such simulations. Maybe millions. Maybe more. Each simulation would contain beings who experience themselves as real, who have no way, from inside the simulation, to distinguish their simulated existence from a non-simulated one. And if simulated universes vastly outnumber the one base reality, as they would if sufficiently advanced civilizations run many of them, then the odds that any given conscious being is in the base reality, rather than a simulation, are very small. We are probably, on this argument, in a simulation. Now, what does the simulation argument do to the question of whether the past exists? In a simulated universe, the past is data. Specifically, the past is whatever the simulation is storing as its record of previous states. A simulation doesn't have to store everything. A sufficiently sophisticated simulation might only compute the regions of reality that are actively observed, storing other regions in compressed form. Like a video game that only renders the part of the world you can see, loading and unloading regions as the player moves through them. In such a simulation, the past exists precisely as well as it is stored. If the simulator keeps complete records, the past is perfectly preserved, retrievable in principle, if not in practice. If the simulator compresses or discards unused states, the past is partially preserved, partially reconstructed on demand. But here is the strange thing. The physics we observe, the holographic principle, the conservation of information, the relationship between entropy and information, looks remarkably like the physics of an information-preserving system. A system designed to keep complete records. A system in which nothing is permanently discarded. If the universe is computational, if it is, in some sense, a simulation, then the perfect preservation of information that quantum mechanics demands looks less like a mysterious fundamental law and more like a design feature. The universe is not losing data. Because losing data would corrupt the simulation. Every past moment is stored. Not because of metaphysics, because of computational necessity. Now, the simulation argument has problems. Serious ones. We do not know if a complete simulation of a quantum universe is even physically possible. We do not know if infinite computational resources are available to any civilization. We do not know if the argument's premises about future civilizations are correct. And there is a more fundamental issue. Even if the universe is computational, it is computational from the outside, from the perspective of the simulator. From the inside, from our perspective, the laws we observe are just the laws. Whether they are implemented on some cosmic computer or whether they are the fundamental structure of base reality, we cannot tell. The physics looks the same either way. But the simulation frame does something useful. It makes concrete what is otherwise abstract. When physicists say the universe conserves information, when they say nothing is ever truly deleted, that is a precise, mathematical statement about how the universe evolves. But it is a statement that is hard to visualize. Hard to feel the weight of. The simulation frame makes it intuitive. Of course the universe keeps records. It's running a computation. Of course nothing is deleted. Deleted data corrupts the output. Of course the past is preserved. The past is what the present is computed from. Whether or not the simulation argument is literally true, the intuition it provides is useful. The universe is behaving like a system that cares about its history. Like a system that needs its past to generate its future. Like a system that has, built into its deepest operating principles, a commitment to never losing information about what has already happened. The universe is behaving as if the past matters. And at this point in our journey, that is less surprising than it would have been an hour ago. We have been a long way from home. We have visited special relativity and the geometry of spacetime. We have walked through the block universe and its strange, static eternity. We have looked at quantum mechanics and its retroactive shaping of history. We have descended into thermodynamics and the statistical arrow of time. We have stared at the holographic principle and the conservation of information. We have grappled with the Wheeler-DeWitt equation and the disappearance of time at the quantum gravity level. We have followed the branching paths of the many worlds interpretation. We have even entertained the possibility that the universe is computational, and that the past is preserved the way data is preserved in a system that cannot afford to lose it. That is a long way to travel. Now let's come home. Because all of that, every equation, every thought experiment, every mind-bending implication, ultimately connects back to something you have felt, probably many times, in the ordinary course of your life. The feeling that a moment matters. The feeling that something that happened is still, somehow, present. The feeling that the past is not simply over. That feeling is not an error. It is not sentimentality. It is not the brain comforting itself with fictions. That feeling might be, in some deep sense, correct. Let's talk about memory. Not the physics of memory. The experience of it. You have a memory, probably more than one, of a moment that felt, in retrospect, like it changed something. A moment where the before and after were genuinely different. Where you walked into a conversation as one version of yourself and walked out as another. Where you witnessed something that could not be unseen. Where something was said that rearranged the furniture of your internal world. You carry that moment. It is not just information stored in neurons, though it is that. It has weight. It has presence. It feels, in a way that is difficult to articulate but impossible to deny, like it is still happening in some sense. Like it is still part of the living present rather than the archived past. You might have thought that feeling was a cognitive quirk. A glitch in the temporal perception system. The brain treating an old memory as more present than it should be. But what if the brain is not making an error? What if the brain, which evolved over millions of years as a biological system embedded in physical reality, is correctly detecting something true about the structure of that reality? What if the feeling that the significant past is still present is not a mistake, but an intuition? An imperfect, fuzzy, humanly constructed intuition, but one that is tracking something real. Something that the equations, approached from a completely different direction, also seem to point at. The past is still present. Not in the way memory makes it feel present, blurry and reconstructed and emotionally distorted, but in the harder, colder, more permanent way of geometry and information and physical law. The feeling and the physics, for once, might be pointing at the same thing. Think about grief. Grief is the most honest relationship with the past that humans have. When you grieve someone, you are not confused about the timeline. You know they are gone in the sense that matters for daily life, that they will not answer if you call, that their chair is empty, that the future you imagined with them will not happen. You are not deluded about this. But grief is also a form of contact with the past. It is a reaching towards something that you know, rationally, you cannot reach. And it is a reaching that feels, somehow, meaningful rather than futile. As if the person you are reaching toward is, in some sense, still there to be reached toward. Every culture in human history has had rituals for the dead. Every culture has treated the past as something that still has presence, still has influence, still deserves attention and care. This is universal. Not because every culture arrived at the same comforting illusion, but possibly because every culture is responding, in its own symbolic language, to something real. The dead are at their coordinates in spacetime. Their information is preserved in the holographic record of the universe. The moments you shared with them are in the block, real, happening, at their addresses. Grief might be the most physically accurate emotion humans have. It insists that the past is real. That what is gone is not nothing. That presence and absence are not the same as existence and non-existence. Grief is right. The past is still there. Now think about creativity. Every work of art, every painting, every piece of music, every story ever written, is an attempt to do something that, if you look at it through the lens of everything we have discussed, seems almost physically exact. It is an attempt to preserve a moment. To take something that happened, an experience, a feeling, an observation, a vision, and encode it in a structure that will carry it forward in time. To make a specific configuration of sound or paint or language that will, when encountered by another consciousness, reconstruct something close to the original experience. A work of art is a technology for extending the past into the future. It is a low-entropy structure, highly ordered, highly specific, that encodes information about a moment and resists the thermodynamic spread of that information into noise. The best works of art feel, when you encounter them, like a direct contact with the past. Not a reconstruction. Not a description. A contact. A moment preserved in amber, still alive, still transmitting. When you read a letter written by someone who died 200 years ago, and you feel something in it, feel the personality, the intelligence, the specific texture of that person's mind, you are receiving a signal from the past. A real signal. Carried in the low-entropy structure of the ink on the paper, the specific arrangement of words, the particular configuration of meaning. The past, in that moment, is arriving. Exactly as the photon from a distant star is arriving. And both of them, the ancient photon and the old letter, are physical phenomena. Both are carrying real information across time. Both are evidence of the same thing, that the past does not simply stop broadcasting. Now think about what this means for how you live now. Not philosophically. Practically. Every moment you are currently living is going into the permanent record. Right now, as you process these ideas, something is happening that is being added, irreversibly, to the structure of the universe. To the geometry of spacetime. To the information content of the cosmos. Not dramatically. Not with fanfare. The universe is not marking this moment as special. The universe marks every moment equally. That is the point. The ordinary conversation you had this morning. The moment of impatience, or kindness, or distraction, or full presence. The choice you made without thinking about it. The word you said, or didn't say. The attention you gave, or withheld. All of it is going into the block. All of it is joining the permanent record. All of it is being added to the four-dimensional structure of your life, which is being extended, moment by moment, into the geometry of spacetime. This is not a reason for anxiety. It is not a reason to feel watched or judged. The universe is not judging the record. The universe is not watching. The universe is simply, and this is perhaps the most extraordinary thing about it, incapable of forgetting. What you do with that fact is the only question that really matters. Let's go back to where we started. A moment from your life that you thought you'd lost. The light through a window. The smell of something cooking. The feeling of a particular afternoon that you didn't know you were in for the last time until it was already over. You reach for it in your mind and you find the shape of it. Blurry. Reconstructed. The imperfect copy your neural machinery preserved. But here is what we now know. The imperfect copy is not all that remains. The original moment, the actual, physical, fully real event, is located in spacetime, at specific coordinates in the four-dimensional structure of the universe. It is as geometrically real as the chair you are sitting in, as the ground under your feet, as the planet you are riding through space. It has not faded. It has not become less real with the passage of time. It is there, at its address, fully happening, in the permanent structure of what has occurred. The information of that moment, every particle interaction, every photon emitted and absorbed, every quantum state that was part of its physical unfolding, is encoded in the universe's ledger. Scrambled, distributed, hidden in correlations between particles scattered across the world. But not erased. The universe cannot erase it. The laws of physics will not permit deletion. And if the many worlds interpretation is right, every branching version of that moment, every way it could have gone, every path that was open at that point in the quantum wave function, is also real, in other branches, equally permanent, equally preserved. The moment you thought you lost is more present in the universe than you are. Now, what do you do with that? This is where physics runs out and something else has to begin. Physics can tell you the past is geometrically real. It cannot tell you what that means for how you grieve, or how you remember, or how you treat the present moments that are, right now, being added to the permanent record. Physics can tell you information is conserved. It cannot tell you whether the person you loved, encoded in quantum correlations across the universe, is in any sense still there in the way that matters, aware, continuous, experiencing. The hard problem of consciousness swallows that question whole. Physics can tell you the block universe is the most natural reading of special relativity. It cannot tell you whether determinism is true, whether free will is real, whether the future is genuinely open or already fixed in the geometry of a spacetime we cannot see from here. These are the questions that physics opens and then hands back. They are handed back not as unsolvable puzzles but as live questions. As things worth holding. Worth returning to. Worth building a life around, if you are brave enough. There is a version of all this that is terrifying. The past is permanent. Every mistake, every failure, every moment of cruelty or cowardice or smallness, in the block. Fixed. Real. As permanent as the orbit of Jupiter. You cannot go back and change it. You cannot reduce its reality by refusing to think about it. It is there. There is a version of all this that is liberating. The past is permanent. Every moment of love, every act of courage, every quiet instance of grace, in the block. Fixed. Real. As permanent as the orbit of Jupiter. You cannot lose it. Time cannot erode it. Distance cannot dilute it. The people you shared it with cannot diminish it by leaving. It happened. It is there. It will always be there. Both versions are true at once. The block universe does not choose between them. It holds them both, in the same four-dimensional structure, with the same unwavering equanimity. What we are left with is this. The universe is older than we can imagine. It has been building its record for 13.8 billion years. Every particle collision, every stellar explosion, every chemical reaction in some ancient ocean that eventually led, through an improbable chain of events stretching across geological time, to something that could sit here and wonder about whether the past still exists. That wondering is in the record too. This video. This moment. Whatever you are thinking right now, whatever this touched in you, whatever question it opened in you that you didn't have before. Going into the block. Right now. Being added to the permanent record of what has happened in this universe. And long after you are gone, long after the star you live near has burned through its hydrogen and expanded and cooled and the solar system has restructured around its remnant, the information of this moment will still be encoded, somewhere, in the correlations between particles. In the quantum states of the universe. In the structure that physical law insists can never be deleted. The universe remembers everything. The only question it cannot answer for you is what you are going to do with the moments that haven't been written yet. Those are still yours. For now. Science does not always arrive first. Sometimes philosophy gets there centuries earlier, standing at the edge of the same cliff, looking down into the same darkness, with nothing but logic and nerve. No instruments. No equations. No particle accelerators. Just a mind willing to follow a thought wherever it leads, regardless of how uncomfortable the destination. The question of whether the past exists is not new. It is not a product of 20th century physics and its strange revelations. It is one of the oldest questions human minds have carried. And some of the people who carried it longest and hardest arrived at conclusions that, reading them now, in the light of relativity and quantum mechanics and the holographic principle, feel less like philosophy and more like prophecy. Start with Augustine of Hippo, North Africa. The late 4th century AD. Augustine was a theologian, not a physicist. He was thinking about God and creation and eternity. But in his Confessions, one of the strangest and most searching books ever written, he turned his attention to time, and what he found there unsettled him completely. He asked, where is the past? It no longer exists in the world. It only exists, apparently, in memory. And the future does not exist either, it only exists in anticipation, in the mind's projection forward. So where, exactly, is time? The past is a present memory of past things. The future is a present expectation of future things. The only thing that actually exists is the present moment, and the present moment has no duration. As soon as you name it, it is already gone. Augustine concluded, somewhat desperately, that time exists in the mind. That time is a distension of the soul, an extension of consciousness that holds past and future together in a single experienced now. He was not satisfied with this. He said so explicitly. He admitted the question defeated him. But what he was reaching toward, the strange unreality of past and future as things in themselves, the peculiar status of the present as the only real moment, the dependence of time on something like experience, these are not naive intuitions. They are sophisticated positions that philosophers are still arguing about today. And when you read Augustine on time, with everything we now know about the block universe and the Wheeler-DeWitt equation and the emergence of time from quantum entanglement, you feel a shock of recognition. The bishop in North Africa and the physicist in Princeton are staring at the same wall. From different sides. Through different holes. But it is the same wall. Fast forward 1100 years. To a Cambridge lecture room. To a philosopher named John McTaggart Ellis McTaggart, who in 1908 published a paper called The Unreality of Time, that remains one of the most provocative and infuriating documents in the history of philosophy. McTaggart made a distinction that became famous. He called it the A series and the B series. The B series is the ordering of events in time from earlier to later. Monday comes before Tuesday. The Big Bang comes before the formation of the Earth. Your birth comes before your death. This ordering is permanent and unchanging. Monday is always earlier than Tuesday, regardless of when you are asking. The B series is fixed, relational, and, crucially, has no built-in notion of past, present, or future. It is just an order. The A series is different. The A series is the ordering of events as past, present, or future. Tuesday was future, then it became present, then it became past. Events move through the A series. What was future becomes present, and present becomes past, and this movement is what we experience as the flow of time. Now McTaggart asked, which one is real? The A series, he argued, is the one that captures what we actually mean by time. The flow. The nowness of now. The genuine passage from future through present into past. Without the A series, you don't really have time, you just have a static ordering of events, like numbers on a line. The B series alone is not time. It is just sequence. But the A series, he then argued, is incoherent. Because the properties of past, present, and future are incompatible. Every event is past, present, and future. It is future before it happens, present when it happens, and past after it happens. But past, present, and future are mutually exclusive. Nothing can be all three. You might say, well, it is future at one time, present at another time, past at a third time. But now you have explained the A-series properties of an event by reference to other times, and those other times also have A-series properties, which require explanation by reference to yet other times, and so on, forever. The A-series generates an infinite regress. Therefore, McTaggart concluded, the A-series is incoherent. But without the A-series, you don't have time. Therefore, time is unreal. McTaggart's conclusion, time is unreal, sounds like the conclusion of a man who had been indoors too long. And many of his contemporaries treated it that way. But look at what the physics says, a century later. The Wheeler-DeWitt equation, no time variable. Time is not in the fundamental description. Carlo Rovelli, time is emergent, not fundamental. At the deepest level, there is no time. The block universe, the flow of time is an illusion. What exists is a static four-dimensional structure. The A-series, the sense of events being past, present, and future, is a feature of experience, not of the structure. McTaggart, with nothing but logic, arrived at the same place that quantum gravity is tentatively pointing. He was mocked for over 100 years. He may have been right. Now move forward to the 20th century, to a philosopher working in Germany whose relationship with time was so deep and so strange that the book he wrote about it, Being and Time, published in 1927, is considered one of the most important and least readable works in the history of philosophy. Martin Heidegger. Heidegger's central claim about time is almost impossible to summarize without losing something essential, but let's try. For Heidegger, time is not a container that things exist inside. Time is the structure of human existence itself. To be human, to be what he calls Dasein, which means roughly being there, the kind of being that is aware of its own being, is to be temporal. Through and through. At every level. We are always already thrown into a past we did not choose, born into a specific time, specific culture, specific language, specific set of circumstances that precede us and shape us before we have any say. We are always projecting forward into a future, anticipating, planning, fearing, hoping, always already oriented toward what is coming. And the present, for Heidegger, is not a thin instant between past and future, it is the site where past and future meet. The living present is always saturated with the past it comes from and the future it is moving toward. We are not beings who exist in time. We are beings whose existence is time. And the most fundamental fact about our temporal existence, for Heidegger, is death. The awareness of our own finitude, the knowledge that we will end, is not an unfortunate addition to human experience. It is its most clarifying feature. It is what makes time feel urgent, meaningful, weighted. Without the awareness of ending, the present moment would have no edge to it, no pressure, no specificity. Death is what makes the present present. This is why the question of whether the past still exists is not, for Heidegger, primarily a physics question. It is an existential one. What is your relationship to your own past? To your thrownness, the circumstances and history you were thrown into and did not choose? Do you run from it, pretend it isn't yours, live inauthentically by denying the past that made you? Or do you own it, take it up as genuinely yours, the material from which you are making a self? The past still exists, for Heidegger, in the sense that it is always already part of what you are. You cannot leave it behind because it is not behind you. It is in you. You are made of it. The self is not a present moment floating free of history. It is a past being carried forward into a future, and the present is always the site of that carrying. Now there is one more philosopher who belongs in this conversation. One who arrived at conclusions so close to the block universe that physicists later cited him as a precursor. Baruch Spinoza. 17th century. Amsterdam. Spinoza believed that reality, at the deepest level, is a single infinite substance. He called it God or nature, Deus sive natura, of which everything that exists is a mode or expression. Space, time, mind, matter, all of it is the same underlying substance, expressing itself in different ways. And for Spinoza, the view from that underlying substance, the view from eternity, what he called the sub-specie eternitatis, under the aspect of eternity, is the truest view. From that perspective, time is not a series of vanishing moments. It is a complete, whole structure. Past, present, and future are all equally real from the perspective of eternity. The temporal ordering of events is real, but no moment is more real than any other. What has happened with the same necessity and the same completeness as what is happening now. Spinoza was not a physicist. He was a lens grinder who thought about God. And he landed, with 17th century tools, on something that looks, from here, remarkably like the block universe. The view from eternity. The static, complete, equally real ordering of all events. Einstein, who kept a portrait of Spinoza in his study, once said that he believed in Spinoza's God, the God of the laws of nature, the rational structure of the universe, not a personal God who intervenes. Whether Einstein was thinking of Spinoza's sub-specie eternitatis when he wrote about the past and future being a stubbornly persistent illusion, we cannot know. But the resonance is there. The philosopher and the physicist, 3 centuries apart, looking at the same eternal structure. Physics does not happen in the abstract. It happens in rooms. In labs with equipment that doesn't always work, run by people who are cold and underfunded and arguing about the interpretation of ambiguous data and writing papers that get rejected and revised and cited and forgotten and rediscovered. The ideas we have been discussing did not arrive as clean revelations. They arrived as the residue of specific, concrete, physical acts of measurement. Let's visit a few of those rooms. Cleveland, Ohio, 1887. Albert Michelson and Edward Morley have built the most sensitive instrument for measuring the speed of light that has ever existed. They are looking for the ether, the invisible medium that, everyone assumes, light must travel through, the way sound travels through air. If the ether exists, then the Earth's motion through it should produce a detectable difference in the speed of light measured in different directions. Moving with the ether wind, light should be faster. Moving against it, slower. The instrument is floating on a bed of liquid mercury to isolate it from vibration. It is the finest piece of experimental apparatus of its era. They measure. They rotate the apparatus. They measure again. They compare. The difference is 0. No ether wind. No variation in the speed of light. In every direction, at every angle, at every time of year, the speed of light is identical. Michelson is disappointed. He considers the experiment a failure. He was trying to detect the ether, and he found nothing. What he actually found was the foundation of special relativity. The constancy of the speed of light, the experimental fact that would lead, 18 years later, to Einstein's 1905 paper, was sitting right there in Michelson and Morley's null result. The most important discovery in the room was the thing they didn't find. The universe had answered a question they hadn't thought to ask. New Mexico. 1941, 10 kilometers above the surface of the Earth. Muons, subatomic particles created when cosmic rays strike the upper atmosphere, are raining down through the sky at very close to the speed of light. A muon's half-life, measured in the lab, is 2.2 microseconds. At the speed they are traveling, They should decay long before they reach the surface. The math is clear, they shouldn't be here. They are here. Experimenters measure them, count them, confirm their impossible arrival. The explanation is time dilation, exactly as special relativity predicts. From our reference frame, the muon's internal clock is running slow. Its 2.2 microseconds of lifetime are stretched, from our perspective, into enough time to make the journey. From the muon's reference frame, the atmosphere is length contracted, the distance it has to travel is shorter. A subatomic particle, created in the upper atmosphere, arrives at the surface of the Earth having aged less than the time physics would normally give it, because it was moving fast enough that time itself stretched around it. Time dilation is not a theoretical prediction. It is a measured, confirmed, repeated, practical fact. The GPS satellites in orbit above you right now have their clocks adjusted to account for it. Without that correction, your GPS would drift by about 10 kilometers per day. The relativistic warping of time is not abstract. It is built into the infrastructure of modern navigation. The past, the moment the muon was created, the specific configuration of spacetime at that point, is connected to the present by a geometry that bends around speed. The muon's personal past is different from ours. Its timeline is compressed. It arrived in our present having passed through less of its own time. Two objects, the same universe, different personal histories of time. This is not philosophy. It is a particle, arriving where the equations say it should, confirming in its flight that time is not absolute, that the past is not a universal shared experience, that the geometry of spacetime is exactly as flexible as Einstein said. A physics lab, somewhere in the world, right now. An experimenter fires a single photon at a screen with two narrow slits. Behind the screen is a detector. The photon passes through. If the detector is set up to show interference, if it is the kind of detector that cannot tell which slit the photon went through, the photon produces an interference pattern over many repetitions. It behaves like a wave. It appears to have gone through both slits simultaneously, interfered with itself, and produced the characteristic ripple pattern of wave interference. Now the experimenter modifies the detector. Adds a witchpath detector, a device that can determine which slit the photon went through. The interference pattern disappears. The photon now behaves like a particle. It went through one slit. The wave behavior is gone. No one touched the photon. No one changed the slits. The only thing that changed was whether the information about which path the photon took was available to the detector. The photon's behavior, its entire character as a physical entity, depended on whether its path information was recorded. Now, the delayed choice version. The photon is fired. It is traveling toward the detector. While it is in flight, after it has already passed the slits, the experimenter makes a choice. Which kind of detector to use? The one that records path information, or the one that doesn't? The photon, already in flight, behaves as though it already knows what the experimenter is about to decide. Choose the wave detector, interference pattern. The photon behaves as though it went through both slits, all the way back to the moment it passed them. Choose the particle detector, no interference. The photon behaves as though it went through one slit, all the way back. A choice made now, about a photon already in flight, determines what that photon was doing in the past. The experimenters who first confirmed this, and it has been confirmed, cleanly, repeatedly, with photons and electrons and even, in some versions, with larger quantum systems, did not take it lightly. They checked the equipment. They checked the timing. They checked whether any signal could have traveled from the future detector back to the past photon through any classical channel. Nothing. The photon simply behaved as though the past were not yet fixed. As though the present were. Completing it. A satellite telescope. 2017. A team of physicists led by Johannes Handsteiner uses light from distant quasars, some of the brightest objects in the universe, located billions of light-years away, as the source of photons for a delayed choice experiment. The photons they detect left their sources between 7 and 10 billion years ago, before the Earth existed. before the sun existed, when the universe was less than half its current age. Those ancient photons arrive at two telescopes in the Canary Islands. The telescopes measure them. The measurement settings, which kind of detector to use, are determined, in real time, by the color of quasar light arriving from different directions. Light that has been traveling for billions of years, from objects so distant they are effectively random and uncorrelated with anything on Earth. The results match quantum mechanical predictions. The ancient photons, whose journeys began billions of years before any human existed, display correlations that depend on measurement settings chosen at the moment of detection. The choice made now, on Earth, in 2017, using light from billion-year-old quasars to randomize the detector settings, appears to influence what photons that have been traveling for billions of years were doing during that travel. If there is a mechanism by which the present influences the past, even in the limited, interpretation-dependent sense that quantum mechanics allows, then it operates across cosmological scales. Across billions of years. Across distances so vast that the photon's entire journey through the universe is implicated. The past is not safe from the present. Not even the very old past. Not even the past that predates the Earth. The room you are in, right now. Here is the last experiment. The quietest one. The one that requires no equipment. You are reading this. Or watching this. Or listening to this. At some point, your attention snagged on something, a specific sentence, a specific idea, a specific moment where something clicked or cracked or opened. That moment is being added, right now, to the permanent record. To the geometry of spacetime. To the information content of the universe. It is going into the block. It will be there, at its coordinates, for as long as the structure of spacetime persists. You are, right now, in the only moment that is not yet fixed. The past is permanent. The past is preserved. The past is real, and geometrically located, and informationally immortal, and in some interpretation still being shaped by what you do next. And what you do next is the only thing that is still open. The universe has given you this one, strange, fleeting, irreplaceable gift. A moment that is not yet past. Do something with it that deserves the permanent record.